Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is Ionic Properties of Nanomaterials from Unit 1 Introduction in Nanotechnology. On completion, the students will be able to understand the ionic properties of nanomaterials and its ionic behavior and also discuss the applications based on ionic effects. Introduction. Nanomaterials generally exhibit unique properties due to their small size, that is in the range of 1 to 100 nanometer, as well as large surface area to volume ratio and quantum effects. Among these properties, ionic behavior becomes significantly different when compared to their bulk materials and also plays a crucial role in fields such as nanocatalysis, nanosensors, energy storage, as well as biomedicine. Basic concepts: ions and ionic properties. Ions are generally atoms or molecules that have gained or lost electrons and become charged. Ionic properties refer to the behavior related to ion conductivity, ion exchange capacity, surface charge and Zettel potential, ionic diffusion and electrostatic interactions. Why ionic properties matter in nanomaterials? Enhanced ion mobility due to short diffusion paths, high surface reactivity for ion exchange, and quantum confinement altering the electrostatic potential are important when compared with the bulk materials rather than in nanomaterials. Size effects on ionic behavior. Here we are comparing the bulk material and nanomaterial for different ionic properties. Ionic conductivity, bulk material it is moderate, whereas in nanomaterial it can be enhanced due to faster surface diffusion. Surface area, it is low in bulk material and very high in nanomaterial due to increased ion absorption or exchange. Ion solubility, it is predictable in bulk material and it is highly enhanced due to high energy surfaces in nanomaterials. Zeta potential, this is less influenced by the environment in the case of bulk material and it is highly dependent on the pH as well as the ionic strength in nanomaterials. Key ionic phenomenon in nanomaterials. Ionic conductivity. Nanocrystalline materials such as ceria, zirconia show enhanced ionic conductivity. The grain boundaries in nanomaterials often serve as fast pathways for ion migration. Ion exchange properties. Nanomaterials like nanozeolites and layered double hydroxides exhibit enhanced ion exchange due to the large surface area and short diffusion lengths when compared with the bulk materials. Quantum and surface effects. Quantum confinement. This alters energy levels influencing ionization energies and surface atoms. Higher fraction in nanomaterials leads to modified local electronic structure and altered electrostatic potential affecting ion adsorption. Applications based on ionic properties. Due to ionic properties, nanomaterials have applications in the area of fuel cells, sensors, drug delivery, as well as water treatment. In fuel cells, due to enhanced ionic conductivity of nano oxides, and in sensors, the role of the ionic property is surface charge sensitivity being improved, improving the detection. Drug delivery. Surface charge affects biodistribution and cellular uptake. Water treatment. Ion exchange and adsorption makes better water purification and treatment with nanomaterials. Examples: cerium oxide, nanoparticle CO2. High oxygen ion conductivity at nanoscale and are being used in solid oxide fuel cells and oxygen sensors. Zeolites and nanoclays. These have high ion exchange capacity for environmental remediation. Titanium dioxide nanoparticles. Surface hydroxyl groups influence zeta potential and better ionic adsorption. Challenges and considerations. controlling surface chemistry for stable ionic behavior, toxicity and environmental concerns due to ion leaching, reproducibility in synthesis and behavior due to sensitivity to environmental conditions. Quiz questions on ionic properties of nanomaterials. Explain the key ionic phenomena in nanomaterials. List down the applications based on ionic properties of nanomaterials. Write down the challenges and considerations of ionic behavior. Thank you.